Hello, everyone. My name is Nagesh Patula. I'm from the Oracle High Availability Management, specifically I'm the product manager for Oracle Sharding and Oracle Global Data Services. Welcome to this AskTom Office Hours on GDS. What we will cover today is the overview of Oracle Global Data Services, which is intended to manage your workload across a set of replicated environments. So we're going to talk about that. So as part of this, we will introduce you to the typical challenges that a customer would face when they're managing workloads across replicated environments, whether it's DataGuard or with GoldenGate. And we'll talk about how GDS addresses those challenges. And then after that, what we'll do is we'll cover the concepts and the architecture of GDS. And then we'll take deeper dive on the use cases and how GDS works with Active DataGuard and how GDS works with GoldenGate, etc. Okay? So we'll cover those. So now, with respect to challenges, there are quite a few challenges when you manage your replicas from workload perspective. I'm going to touch upon a couple of interesting pain points. So number one, it's the balancing of the workload. When you have a replicated environment, let's say in this example that I'm showing on the left-hand side here, I have a primary database in data center 1, active standby in data center 2, right? Let's say if I have read-only workload that needs to be run, right, across these, that needs to be load balanced across these. Before GDS, there is no vehicle for me to manage the read-only workload, load balance it across databases, right? So we thought what happened is we have overutilized server on one side and underutilized on the other side, right? In essence, you have suboptimal resource utilization, right? That's just one of the pain points. And the other one is, let's say you're running your read-only workload on the standby, and if that standby goes down, there is no automated mechanism with which you can fail over your service from one database to the other, right? Let's say in this case, my active standby went down. I can't have a failover of this service from here to the primary in this example, right? Without which the applications will undergo an outage. Okay? So these are just two pain points, and there are plenty of pain points we can talk about at length. But what happened is customers have reached out to us as part of the customer advisory board, and then they mentioned that there needs to be a technology that addresses these challenges. So Oracle's response to that request is the Global Data Services, which was released as part of 12.1 back in 2013. Right? So what is GDS? It's a automatic and transparent client workload management across replicas. Right? It's a vehicle with which you can manage your workloads seamlessly and transparently and automatically across a pool of replicated databases. If you step back and look, in a typical rack databases, when you have multiple instances, we have enabled service level failover across instances, service level load balancing, both connect time and runtime across instances. With GDS, what we have done is we've extrapolated that notion of service failover and load balancing across databases. Right? So in rack, you can do across instances, but with GDS, now you can do across replicated databases, the service failover and load balancing aspects. Okay? And we have created a new notion called global service, which is offered over a pool of replicated environments. And all of this will be covered in detail in the subsequent slides. Right? So now, capabilities-wise, GDS offers few things. The workload routing based on the load of these databases, based on the locality, the region where the databases reside on, and also based on the replication lag. Right? Based on those, GDS routes the workload accordingly. Okay? And then it offers service failover across replicas as well. If a database crashes, it immediately fails over that global service from one database to another database based on the policies that you get to set. And I'll show you how you will set with simple modification to a global service attribute. There is no custom code that you would have to write. All you would do is change the attribute of the service, specify the service attribute, and then you get the behavior that you want for your workload across the replicas. So benefits as a customer, what would I get? I would be able to maximize my application performance with locality-based routing or with real-time load balancing. I get to maximize my application performance, right? The second one is the mitigation of downtime, whether it's planned outage or unplanned outage. You will be able to mitigate your downtime with GDS. And I'll show you how to configure your environment to achieve these capabilities. And the last one is interesting. You could have numerous replicated environments and numerous replicated databases. You get to manage all your resources with single interface. Right? If you want command line interface, we have what's called as GDS CTL. And if you want to use GUI, EM is also available for GDS as well. Okay. So now here is this example on the right-hand side. With GDS, basically your workload is well balanced and well distributed across databases. And if a database goes down, we automatically fail over the service to another database, and we let the clients know that the service has failed over. So now the clients react to it and automatically connect to the new location where the service is being offered. Okay, so that's GDS in a nutshell. Now, from architecture perspective, when you enable GDS, right? Let's talk about the components. Right? But before we touch on the components of GDS, let's talk about what's in the overall architecture. At the bottommost tier, you have database tier, where you have a set of replicated environments. I'm just showing you two here, but you could have numerous databases in that replicated pool, or you could have multiple sets of databases. Okay. So now in this example, I have sales pool where there's a primary database and there's a standby database. That's in the database tier. And the application tier are typically running Oracle integrated connection pools, whether it's UCP, OCI, ODP.NET, etc. Right? And in the middle, when GDS is enabled, you have this layer. You have two components here. One is the global service manager, and the other one is catalog. Catalog, think of this as a small scale repository which pursues the metadata of your GDS infrastructure about what are the regions, what are the databases, what are the global services that are running, right? All that basic information is persisted in the catalog, and we recommend that it needs to be replicated for high availability using the Active Data Cloud. That's catalog. And then there is another component called Global Service Manager. Think of this as a global smart listener. Right? It's regular listener code, but that's been empowered in support of a distributed environment. Okay, so starting from 12.1, just like how you had database media and client media that you have used before, you have what's called as GSM media, the Global Service Manager media, that you would download and install on small-scale VMs, a pool of them. In this example, I have 3 GSMs in region 1, 3 GSMs in region 2. Right? These are the listeners that your applications will connect to talk to any database in the pool. Okay, and this is not active standby type of listener configuration. These are all active. Like your application clients can connect to any of these GSMs, and they're still getting connected to the databases based on the policies that you set. Okay, so GSMs do a few things. One is the connection load balancing. The incoming connections are well load balanced across these databases. And it's not only connect time, it also provides runtime load balancing advisory. Right? So back in RAC allowed you to get runtime load balancing advisory by publishing the RLB advisory back to the connection pools, and the connection pools receive this information and route their workload across these instances in a cluster. We do the same thing, but now across databases. So I could have 4-node rack cluster here, 4-node rack cluster here. And I can get real-time runtime load balancing across these instances from multiple databases, right? So connect time load balancing, runtime load balancing, and the other one is service failover, right? So when a database crashes, GSMs recognize this and automatically fail over that service from one database to the other. Okay, and we'll talk about these use cases later on as well. So there are a couple of other things that we want to touch upon. There's a notion called region. A GDS region is nothing but, in its simplest form, it's analogous to a data set. Right? But if you have multiple data centers, you can model them as a single GDS region as well. Right, so the region is there. We talked about catalog, we talked about GSM, and then the other one is the global service. Global service is nothing but a regular local service that you've been using all along, except for new attributes have been added in support of a distributed environment. Attributes such as locality, replication lag, load balancing goals, etc. Those are the new attributes that have been added to the service concept. Okay. I showed this GDS infrastructure here. You may think, oh, I need to have these GSMs catalog for one set of replicated databases. No, you could have, basically GDS infrastructure is a shared infrastructure. You could deploy this one time, and you could have multiple sets of replicated environments like this. Like in this example, I have sales pool, and I could have HR pool, and I could have a series of pools, up to 20 such pools in governed by one single GDS infrastructure. Okay, and I could have 5 GSMs in each region. I could have 10 regions altogether, and I could have numerous thousands of database instances. Okay. So now, from deployment perspective, how do I deploy GDS? It's actually quite simple. Let me illustrate what are the high-level steps. The first thing that you would do is, as I said, you would download the GSM media and install it on the specified nodes. Typically, we recommend you to have 3 GSMs per region for high availability and scalability. The minimum you want at least 1 GSM per region. The second step is to pre-create a catalog database, like how you have Armine catalog or Enterprise Manager repository. With GDS, you have a small-scale catalog database called GDS catalog. You want to pre-create the database, so later on you can create your GDS catalog schema in that database. Okay, and we require you that all the GSMs and the catalog and the GDS databases are all equal to or greater than 12.1. Ideally, you want to be at 12.2 because that's the latest release that we have. So once the catalog is created, now there are some basic administrative accounts and privileges that you need to set up. And I'll show you what those are. These are the default accounts that are automatically created when a 12-seat database is created, such as GSM user or GSM cat user, etc. And those have to be unlocked, and you specify a password. So once those catalog accounts and privileges are taken care of, there are a bunch of one-liner commands that you would execute as part of GDS CTL. The creation of catalog, addition of GSM, the addition of region, pools, databases, global services. So basically, with one-liner commands, you would specify these and you configure your GDS environment. Once the environment is configured, you would change your client connectivity. Instead of the TLS names reflecting Oracle scan listeners, or for that matter, database listeners, now you will modify that to include GSM listener endpoints, right? So that's an important change that you would do, and I'll show you some examples in the subsequent slides. Okay, so let's assume that you download a GSM and install it on the GSM servers, and you pre-created the catalog. So the next step would be to manage your administrator accounts. Let's look into that. Okay, here are those steps. On the catalog database, right, the database that you specified for the catalog, you would create a super user. In this example, I'm saying my GDS admin, and you specify a password, and you grant a role called GSM admin role to that super user. Okay. The second step that you would do on the catalog database is you would unlock the GSM catalog user, and you set the password. Likewise, on each of the GDS pool databases, the replicated databases that we talked about, there is again the GSM user that's automatically created. You would unlock it and you set your password. So these are the prereqs that you would do on each of the GDS pool databases and the catalog. So now what's the next step? The next step is to run a bunch of commands that will set up your GDS for your environment. So I would run catalog, so I create catalog. I specify what database I want to create this catalog on, and what's my super user, and what are the regions that I have in my environment, right? Let's specify that here. And you're running all this in an interface called GDS CTR. And then you say add GSM, and you specify your listener endpoint. The port is 1571 in this example, and what catalog it's mapped to, right? The catalog database, and what region that it belongs to. Likewise, you create a pool of GSMs, one set for region 1 and the other set for region 2. Okay. After the GSMs are added, you will start them with this command called start GSM. And then once that's done, now you will add databases to the pool. So you create a GDS pool called sales. It's right. It's a logical container, and then you add your database to that pool. Right. With this example, I'm adding database 01 and database 02 to that pool called sales, and here are the regions that each of these databases are residing on. But if you're using broker, then you don't need to do add database. You could say add broker config, like I show here. Okay. So your broker could have numerous databases, let's say 1 primary and 9 standbys. All of those 10 databases can be plugged into one GDS pool with one command called add broker config. So once those databases are added, you would say add service. This is what the global service that I was talking about. So you would say add service command, give the name of the service, what pool that this service will run on, and you want to define those attributes, the preferred and the available. Preferred in this example is DDO1, available is DDO2. Preferred goes down, service will fail over to available database. And then once you define the service, you would go ahead and start the service. Okay. So now the service will be running on the databases based on the policies that you set. Okay. So that's done. Now, what are the changes from the application side? How would my TNS connectivity look like? This is very similar to what you've been used to. So my TNS entry would list an alias, and I would follow the max availability best practices and specify the connect time out, transport connect time out, retry count, retry delays. All these things are not new concepts, but we just want to retain them back for GSMs also, right? Because those are listeners. And then I'll specify 2 buckets. One address list for region A, the other address list for region B. And I would list each of the GSMs in that region and each of the GSMs in the second region as well, and the specified ports. Right? So again, like I said, there's no difference from what you've been used to in terms of the syntax of this. The important thing to note here is the service name will be the global service that you just created. And then optionally, you can specify the region that this client is coming from, whether it's east or west. And I'll show you why this is important, especially when you want locality-based routing, right? And I'll talk to that later. So that's the client connectivity aspects. Now, for an application to be GDS ready, what are the requirements? Okay? But I want to step back a bit and talk about an important point. So GDS relocates the service. It manages your services based on the configuration you set. It also does an important thing. It also publishes notifications. Anytime there is a service failover or there is as an event that needs to publish, GSMs will publish an event back to the connection pool. Right? Whether it's service failover events or RLB, the runtime load balancing metrics, these events are published by GSMs to the connection pools via what's called as ONS channel, Oracle Notification Service. And that's the beauty of GSMs. It's not just simple failovers of global service. It's the intelligence that it provides to the connection pools, with which the connection pools now become smarter and navigate the workload intelligently with absolute minimal downtime. Okay, and I'll show you that. I'll walk you through those requirements now. So first thing first, we talked about you have to have global service for a GDS-enabled architecture. You would want to use Oracle Integrated Connection Pools, OCI, JDBC, ODP.NET, and WebLogic. We also support these third-party Apache Tomcat, WebSphere, JBoss as well. But if you want to use those, we recommend that you would use UCP as a data source. And then the connection URL, the TNS entry, should include the GSM listen endpoints, the MA best practices on the timeouts and the retry delays, the global service name, and the region attribute. right? We touched on these things in the last slide. And if you're using 12.2, the fast connection failover is automatically enabled, and which is what you want to subscribe to the honest notification that GSMs publish, right? The intelligence that it publishes, you would get by using 12.2 clients automatically, right? If you're using pre-12.2, then you would want to explicitly call this set fast connection failover enable, and then that will allow you to subscribe to the ONS events. And then there's another, for UCP, there's another attribute called the planned draining period, wherein you want to gracefully move workload from one database to the other instead of immediately switching over, right? So over a period of 30 seconds, you want the workload to be moved from one database to the other. So we gradually drain out. Okay? So those are the requirements. Now what we're going to do now is we'll talk about the use cases. So far we touched on what are the challenges, how GDS addresses those challenges. We talked about the concepts and architecture. We talked about how do we do a deployment for GDS configuration. We also talked about the application modifications, okay, to get the GDS intelligence. Now we'll go into the use cases part. So here in this example, I'm going to walk you through the service failover. This is for GoldenGate master replica configuration. So if you take a look at it, I have two regions, data center 1, 2, and I have GDS enabled, and I have at the database tier, I have two databases. One is the master, which is DB01, the replica is DB02. The order entry service is running by the master, and my goal is if my master DB01 crashes, I want this service, order entry service, to fail over to DB02. Okay, to get that behavior, all I would do is I would define my global service as follows. Define your global service, specify it, what pool it resides on, and what's the preferred, what's the VM. Right? So what happens is when this crashes, we automatically recognize this and fail over this service, the global service, to this replica, and we let the clients know that there is a service event that has occurred. And then automatically connection pools will recognize this, and they close their connections on the previous previous master, and open the connections automatically to the new master. Okay. So that's the service failover for GoldenGate master replica. This is an interesting one. A lot of customers use this in production today. Load balancing for reader farms. So here there is one. This is applicable to both to DataGuard as well as GoldenGate. So there is one master database where all the read-write workload happen, and the read-only workload runs on the reader farm, which is a pool of databases that are running in the quote-unquote standby mode. Okay, so my goal is I need to have, of course, in this case, two services: one for read-write, another one for read-only. But my goal is to load balance the read-only workload across the reader farm databases. Right. So to get that, I would create one database service, one global service for the order entry, and the second service is for the reporting service. On this service, on this pool called sales, right? Preferred all, that means it can run on any database as long as the role is physical standby. That means it's going to run on these three databases, which are running on the standby mode. And then the two more attributes that I'm setting here, one for connection load balancing, go long for the long-lived connections, and the RLB goal for using, in this case, service time. I have two options, either service time or throughput. So I'm using service time for the RLB goal and long for the connection pool-based clients. Okay. So once I define my global service this way, and I use this particular service in my TNS names, all my incoming clients will be nicely load balanced across these standby databases for the reporting service. Right? So as you see, there is no custom code that you would have to write for load balancing across databases. All you do is specify the attributes for your global service and use that global service in your TNS names or in your URL. Right? And that's all about it. And then GDS will do the trick of load balancing the workload. The next one is load balancing for active GoldenGate. Okay. So in this example, I have two databases, master DB01, master DB02. The assumption is the application handles the multi-master conflict resolution using the GoldenGate framework. And my goal in this case is I want to load balance my workload across these databases. But this time around, it's not just read-only workload that I'm load balancing, it's the read-write workload that I'm load balancing across these databases. So now to get that behavior, I would create the service called order entry service, which is running on the pool called sales. I'm saying preferred all, that means it can go on any database while honoring the connection load balancing goal long. Right? So with that set, with this global service defined this way, all your incoming connections will be well balanced and well distributed equally across these two master databases. And this includes both read-only as well as read-write workload. Okay. The next thing is region affinity. It's the same example that I have used before. And my assumption is the application has handled the multi-master conflicts. Now, my goal in this case is clients closer to the data center 1 should be routed to a database near data center 1. Likewise, clients closer to data center 2 should be routed to a database in data center 2. Right? So I want to go to the nearest database. So now, for this to happen, the two requirements. The first requirement, of course, is the global service definition. So in this example, order entry service, preferred all, it can go to any database, but the key attribute is the locality. That means I'm telling the system that, your first choice is to take the clients to the local database in this local data center. If the database in the local data center is down, then the second option is to go do a region failover to the other database, which is in data center. That's what you get for region failover, right? So again, your first priority is a local database. And if the database is not available, then you would go across to the other database in the other region. So that's the first step. You define the global service that way. But in your TLS lanes, there is a region attribute we talked about, right? That region attribute has to be defined. If, let's say, I have clients in West coming from the Western data center, so you want to specify region West. So basically, you're telling GDS, hey, I'm coming from West, so take me to a database in West. Likewise, if clients define East in the region, those clients will be taken to a database which is in the Eastern region, right? So that's how the locality-based routing works. Service failover active data guard. So we know that active data guard, whether it's switchovers or failovers, they do role transition. Right? Primary becomes standby, standby becomes primary, etc. So now, when this role transition happens, our goal is to have this global services come up based on the role of the database that you define. Right? So, for example, in this case, for example, let's say I have my primary database and order entry service is running on the primary database, and the reporting service is running on the standby. Right? If my standby goes down, right? If my standby goes down, as a last opportunity, I would want my reporting service to go back and run on the primary. Right? So I want to be able to relocate my service, my reporting service, back on the primary if the last node standby is down. Right? So to get that behavior, I would define my reporting service this way. I would say preferred all. That means it can run on any database. The first choice is run this service on the database that's currently in the role of a physical standby. But if the last known physical standby is down, you have the option of failing over to the primary. That means the service can come up on the primary as well. Okay, so that's the service failover for active data guard. If a standby goes down, you can automatically relocate your reporting service back on the primary. And then after the service is relocated, GDS will tell the clients that the service has been relocated. Now go ahead and adjust your pool. So now the role-based global services that I mentioned. So in this example, I have order entry service running on the primary, reporting service running on the standby. When the role transition happens, whether it's manual switchover or a manual failover, or for that matter, fast start failover. So the moment this role transition finishes, GDS will automatically relocate the global service based on the role that you've defined. So this is how I define my global service. One for order entry service, It's preferred all, role primary. And the other one is reporting service, which is again preferred all, role physical standby. If the database roles change due to the role transitions of data guard, we automatically relocate the global services, and then we let the clients know that the services have been relocated, and the clients realize this and again adjust the flows. Okay, basically they close the connections on the older database and open the new connections to the new database where the services come up on. The routing based on replication lag tolerance. This is an interesting one. In this example, I have a primary database and a local standby, and also I have a remote standby in a remote data center. And many a times, due to network issues, there could be latencies established or created, let's say for this remote standby database, and this could be lagging behind the primary. And if your applications are accessing this particular database that's lagging behind, they may see data that's not current. It's kind of stale data, right? And maybe your application or business does not want you to do that. So you could specify what's the acceptable tolerance for that particular replication lag. Okay, and you define that in seconds. Let's say 180 seconds. And then you'd say 180 seconds is my maximum threshold. And if that replication lag exceeds that threshold, what we do is we shut down the service and we route the next set of incoming connections to another standby whose replication is not lagging behind by 180 seconds. Okay, and to get that behavior routing based on replication lag tolerance, this is how you define your global service. You say preferred all, role physical standby with the replication lag over 80 seconds. That's your tolerance. Okay. So the important thing is here is this replication lag tolerance is currently supported for Active Data Guard, and it's also this particular feature will be supported for GoldenGate as it's in the product roadmap. It's going to happen sometime in the next few releases. Okay. Mitigation of unplanned outage with Oracle GDS, and also we'll talk about the planned event as well. Okay, now how do I mitigate the unplanned outage? First of all, we just have to follow the requirements we touched upon in the earlier slides. The application must be using the Oracle Smart Clients. The application should follow the best practices that we talked about. Unplanned events, in this case, the service failovers, right? Anytime there is a service failover, if a primary database crashes, or for that matter, even the data guard role transition for faster failover, etc. When those events happen, the moment GSMs realize it, it relocates the service and it'll tell the clients. So the clients receive notification, the fast application notification. And the moment the clients receive the notification, fast connection failover ensues, right? As part of fast connection failover, the new work is redirected by GSMs and GSM listeners immediately, right? So they redirected to the new database where the service has come upon. The idle sessions that will be released immediately as well. The idle sessions on the older database will be cleansed out. But the checked out connections, which were running on the older database, they receive an invalid connection. So the application would close the connection and obtain a new connection. And this time around, when they obtain a new connection, they will be redirected to the new location of the database where the service has come up. And this happens completely automatically, right? This is the behavior of the connection pools. GDS will publish this notification and gives that intelligence to the connection pools, so that the connection pools can now move the workload from one database to the other seamlessly and transparently. So now how about the zero downtime plan maintenance, right? So same requirements for the applications and application configuration. Now here, the example could be, I have two databases, OGG1 and OGG2, and I have a patch, an application patch, a schema upgrade or PL/SQL upgrade that I want to apply to the OGG2, right? So I'm going to apply the patch on OGG2, and now patch is good. Now I need to remove my workload from OGG1 to OGG2. With the simple command called relocate service that I run from GDS-CTL, I would move the workload from one database in one data center to another database in another data center. Right? I specify what's my old database, what's my new database. right? So you relocate the service will fail or get relocated to the new database, and then FAN notification gets published by GSMs. So now again, the connection pools receive this event, and then the reason in this case is user, because it's not a unplanned event, it's a planned event, and the FCF drains again. So as part of the FCF draining, the new work is redirected by GSM listens immediately, idle sessions are cleansed out, and the active sessions, the OLTP active sessions, they will come back to the clients once they commit or once they close the transaction. They'll come back once the connections are checked into the pool, right? And basically, you're waiting for those connections to finish off the pending work, and once they come back to the pool, they will be cleansed out, and then the new connections will be open to the new database where the services are running, right? Again, this is completely transparent to the application. As long as you follow the best practices here that I showcase, and you just run one command called relocate service, right? So you can mitigate your downtime in that way. So bottom line, GDS is a vehicle with which you can manage your replicated environments, and you can do routing, load balancing, and service failover across these replicated databases. The benefits for your applications is that you get to maximize the performance with load balancing and locality-based routing. You get to mitigate your downtime, whether it's planned or unplanned, with nice failovers with the intelligence that it provides back to the connection pools. And the best part is you'll utilize your replicated environments effectively. You don't have underutilized resources or overutilized resources, right? So you have to manage your workloads with simple interface, whether it's GDS CTL or with the enterprise manager. Okay. Last slide, I want to touch on a few things, right? If you want more information on GDS, I would strongly encourage you to go to the Oracle GDS OTN portal, www.oracle.com, go to /GDS. There is plethora of information there. You have webcasts, cookbooks, documentation links, and you have viewlets that you may want to take a look at it, etc. Right? I also strongly urge you to take a look at my blog post in my blog site on GDS. There I talk about the internals of GDS that we talked about today, and likewise do follow me on Twitter to get various information on GDS as well.